Kinetics. It is the branch of chemistry that deals with the study of reaction rates and their mechanisms. Rate of reactions. It is the change in concentration of reactants or products in unit time. The unit of rate of reaction is mole liter inverse time inverse. A plus B to C plus D. Rate of disappearance of A equal minus the concentration of A by dt, where the concentration of A is small change in concentration of A and dt is small interval of time. Rate of disappearance of B equal minus the concentration of B by dt, where the concentration of B is small change in concentration of B and dt is small interval of time. Rate of appearance of C equal plus the concentration of C by dt, where the concentration of C is small change in concentration of C and dt is small interval of time. Rate of appearance of D equal plus the concentration of D by dt, where the concentration of D is small change in concentration of D and dt is small interval of time. Rate equal to minus the concentration of A by dt equal minus the concentration of B by dt equal plus the concentration of C by dt equal plus the concentration of d by dt. Rate law or rate equation. It is the expression which relates the rate of reaction with concentration of the reactants. The constant of proportionality K is known as rate constant. Average rate. It is the rate of reaction measured over a long time of interval. Rate equal to minus the concentration of A by dt equal minus the concentration of B by dt equal plus the concentration of C by dt equal plus the concentration of D by dt. Average rate equal to del x divided by del t, where del x is change in concentration and del t is large interval of time. Instantaneous rate. It is the rate of reaction when the average rate is taken over a particular moment of time. Instantaneous rate equal to dx by dt, where dx is small change in concentration and dt is the small interval of time. It is the expression which relates the rate of reaction with concentration of the reactant. Rate constant. When the concentration of reactants is unity, then the rate of reaction is known as rate constant. It is also called specific reaction rate. The constant of proportionality K is known as rate constant. Molecularity of a reaction. The total number of atoms, ions or molecules of the reactants involved in the reaction is termed as its molecularity. It is always in whole number and is never more than 3. It cannot be 0. Order of a reaction. The sum of the exponents power of the concentration of reactants in the rate law is termed as order of the reaction. It may be 0 fraction small integer 1 to 3. If rate law expression for a reaction is rate equal to K concentration of A to the power x concentration of B to the power y, then its order of reaction equal to x plus y. Order cannot be determined with a given balanced chemical equation. It can be experimentally determined. Rate law for zero order reaction. R2P dx by dt equal to K concentration of R naught, K equal to concentration of R naught minus concentration of R by T. If we plot a graph between concentration of R versus time t, the graph is a straight line with slope equal to minus K and intercept is equal to concentration of R naught. Half-life of a reaction. The time taken for a reaction when half of the starting material has reacted is called half-life of a reaction. For zero order reaction, the half-life time is T half equal to concentration of R naught divided by twice K. For first order reaction, the half-life time is T half equal to 0.693 divided by K, where K is rate constant. It is independent of initial concentration for first order reaction. Rate law for first order reaction. R2P K equal to 2.303 divided by T log concentration of R naught divided by concentration of R, where K is rate constant or specific reaction rate. Concentration of R naught is initial molar concentration. Concentration of R is final molar concentration after time t. K equal to 2.303 divided by T log A by A minus X. where A is initial concentration reacted in time t, final concentration after time t is A minus x. If we plot a graph between ln concentration of R with time, we get a straight line whose slope equal to minus k and intercept ln concentration of R naught. To calculate rate constant for first order gas phase reaction of the type A to B plus C, k equal 2.03 divided by T log Pi divided by twice Pi minus Pt, where Pi is initial pressure of A, Pt is total pressure of gaseous mixture containing ABC, Pt equal to Pa plus Pb plus Pc. Pseudo first order reaction. The reaction which is bimolecular but order is 1 is called pseudo first order reaction. This happens when one of the reactants is in large excess. Example, acidic hydrolysis of ester, ethyl acetate. Activation energy EA. It is extra energy which must be processed by reactant molecules so that collision between reactant molecules is effective and leads to the formation of product molecules. Arrhenius equation of reaction rate. It gives the relation between rate of reaction and temperature. K equal to A to the minus Ca by RT. ln K equal to ln A minus Ea by RT. Log K equal to log A minus Ea by 2.03 RT, where K equal to rate constant, A equal to frequency factor, Ea equal to energy of activation, R equal to gas constant, T equal to temperature in Kelvin. Log K2 by Ka1 equal to Ea by 2.03 R T2 minus T1 divided by T1 T2. Probability factor or steric factor. Rate equal to P ZAB e to the minus Ea by RT, where ZAB represents the collision frequency of reactants A and B. E to the power minus Ea by RT represent the fraction of molecules with energy is equal to or greater than Ea, and P is called the probability or steric factor. Mechanism of reaction. It is the sequence of elementary process leading to the overall stoichiometry of a chemical reaction. Activated complex. It is an unstable intermediate formed between reacting molecules. Since it is highly unstable and it readily changes into product, rate determining step. It is the slowest step in the reaction mechanism. The number of collision per second per unit volume of the reaction mixture is known as collision frequency Z.